Hello viewers, you're welcome once again. We are going to treat tautology still under logic. Let's write the topic. Tautology. What is tautology? We said that tautology is a statement form that is always valuated to be true for each possible combination of the truth values of the simple statements that constitute the statement form. It means the statement is true for each truth valuations. That is the definition of tautology. It says it's a statement form that is always valuated to be true for each possible combination of the truth values of the simple statement that constitute the statement form. That is to say that in tautology, when a statement is being valuated to be truth, that is, the truth valuation is always to be truth for each possible combination of truth values of simple statements. That means anyhow you combine the values of simple statements, it will be valuated to be truth. That's what we call tautology. That means that all the whole truth valuations will be truth. So there will be nothing like false, always truth. That's what we mean by tautology. Then we say that there are two methods. There are two methods to prove that a statement is tautology. Namely, one truth table. Okay, let's use red ink. So 1 is truth table. 2 assumption of truth valuation. Assumption of a truth valuation. He said there are two methods to prove that a statement is a tautology. Lately, one is by truth table. We can use truth table to prove that a statement is a tautology. Second one is by the assumption of a truth valuation. That is, we assume whether the statement is true or false. So, but you always assume that it is false. But if you arrive to a contradiction, you know that it is truth, so it is tautology. So we assume that because you know that a statement can never be false, it is assumed to be truth. So we assume that it is false. If there is contradiction, you know that it is truth. So, but we are going to show how to prove them by following examples. Example, use truth table to prove that P implies Q and Q implies P. So Q implies R implies P implies R. We want to use truth table to prove that P implies Q and Q implies R implies P implies R is tautology. So he said that you should use truth table to prove that P implies Q and Q implies R implies P implies R is tautology. Now let us prove it. If we can be able to arrive, that is, all the whole truth valuation indicate truth value, that is, the truth value is true. If all of them for each possible combination of simple statements, that means it proves that all the whole truth value, they are truth. You know that it is tautology. Now we write a statement, the stated form. Let's write it. P implies Q and Q implies R implies P implies R. Then let us use our abbreviated statement, abbreviated truth table. That means you want to use abbreviated truth table. You know that we have P implies Q. That means number one, P is a statement, simple statement. One, Q is also a simple statement. Two, Q is still two, R 3. P is still 3, R is still 3. That means they have 3 simple statements that are involved in this statement form. That means we are going to have 8 possible ways we can combine the true values of the simple statement. And we know the idea to get our possible combinations of truth value. We have number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, to 100, to 1,000, to 1 million, 10,000, billion, trillion, and so on. So all the whole number that involve 0 and 1 is what we are going to pick one after the other. As it is one after the other, we pick them. Those numbers that involve 0 and the 1. And those numbers are 1 is 0. We have 0, we have 1, we have 11, we have 100, we have 101, we have 110, and 111. So these are the numbers. Since we have 3 simple statement forms that are involved in this statement, that means our formula is 2 power n. Why that n denotes the number of simple statements that are involved in the statement form. And that means we are going to have 2 power 3, that is the number of simple statements that are involved in the statement form. That means 2 power 3, which is equal to 8. That's why we stop at what? At 8. So if you count, we have 1, 2, 3, 4, 5, 6, 7. That is the one we're missing. We have, we have here, we have 10, we have 11, we have 100, we have 101, we have 111. That means we have 8. 1, 2, 3, 4, 5, 6, 7. You see Mr. Another one. You have 1, you have 0, 1, 10, 11, 100, 101, 110, 110, and then 111. So that these are numbers that are involved 0 and the 1 in our normal numbers. So but here we have only 1 0. We are going to have 3 simple statements. It represents only 1 simple statement. We are going to add 2 more 0 in front of it to make it 3. That means I have 0 0. Here also have only but 1. I'm going to add 2 more in front of the 1 to make it 3. 0 0. Here you have 2, so you add 1 more to make it 3. You have 2, and also 1 more 0 to make it 3. So we have now obtained the possible ways we can combine our truth value. But here you know that we are using T and the F as our truth value. So anywhere we see 0, it is F. Anywhere we see T, substitute with T, truth. So here, but if you like, you can start from 0, from lowest to highest. But you want to start from highest to lowest. So we have under P, we have 1 1 1. That means true true true. So P here, under each simple statement, you're going to represent a statement value, a truth value. That means here we have P, here will be 1. Also use blue ink. Here we have 1, 1, 1, 11. That means we have truth, the Q also truth. Under R, we have also truth. Then here you have 110. So under T, under P, we have T. Under Q, we have T, because I have 110. Then under R, we have F. Then you have 101. That means under T, we have T. Under P, we have T. Under Q, we have F. Under R, we have T. Then under, we have 100. So under P, we have T. Under Q, you have F. Under R, we have F. We have also 100, we have 11. That means under T, we have F. Under we have 11. Under P, we have F. Under Q, T. Under R, T. Next one is 10. That means under P, we have F. Under Q, we have T. Under R, we have F. Then we have 1. We have 1. So under, that means 0, 1. Under T, we have F. Under Q, we have F. Under R, we have T. Last one is 0, 0, 0. That means under P, we have F, Q, F, then R, F. That is that. Then repeat it to other remaining statement value that are involved in the simple statement. Here is Q. I have gotten the values of Q. Just copy it here. This one here. Under this Q, copy this one also here. Under this Q, we have T, 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 F, T, T, F, F, T, T, F, F. Very good. Copy also the P's here, also under here. You copy the P, the truth values of P. You have T, 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 F, 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 F. Under R, also you copy the same thing here. Under R, you have T, F, T, F, T, F, T, F. Very good. Knowing that our automatic, if you remove the outer bracket, you will get this implied as our main connective. That means this whole statement implies this one. So this is our main connective. But let us evaluate other compound statements that are constitute the statement form. We have P implies Q. P implies Q. You know that it will only be false when the antecedent is truth, while the consequence is false. That's only when it can be validated to be false, otherwise truth. So here you have T false. That means the P is that is the antecedent is truth, and Q, which is consequent, is false. That means here it is false. Here you have also TF, it is also false. Here is FT, no, FT, no, FF, no, FF, no. So the rest they are truth. So here is T, 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 here is T. Now let us separate this one also. You know that here Q is the antecedent, while R is the consequent. So anywhere P is T and R is F, you know that it's going to be what? Going to be false. So here you have T, F. That means the antecedent is truth, while consequent is F. That means it's going to be F. Here you have FT, no. You have FF, no. TT, you know. Then TF. That means Q is T, R is F, so it is false. Here. Now we know that here you have FT, FF, so otherwise all of them, otherwise they are truth. That means the remaining valuations they are truth. That means here is T, here is 3, here is T, here is T, here is T, here is T. That is that. Then move ahead. Now let us evaluate this compiled statement here. We have P implies R. That means anywhere P is T and R is F, you know that it is going to be what? F. That means the antecedent is truth, the consequent is false. Here you have TF, that means here P is T, R is F, so it is F here. Here you have TT, you have TF here, it's also F here. Here is FT, FT, FF. So the remaining valuations they are truth. That means here is T, 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 here is T. Very good. And you know that this statement, this and this, they are being combined. This statement, P implies Q and Q implies R, they are being combined by this conjunctive connective. That means this and connective. So, and we know that we can evaluate conjunctive statement to be truth when the two conjuncts are truth. That means the conjuncts they are truth. That's when we can evaluate a conjunctive statement to be true. That means here, this statement here, which I've already validated should be true, and also here, which I've already validated to be also should be truth. So we're looking under this connective now, these two connective now, to use to validate this conjunctive statement, that is and connective. So here is T, here is T, so it is T. It is T. Here is F, here is F, no. Here is F, here is T, no. Here is F, here is T, no. Here is T, here is T, so it is T. Here is T, here is F, no. Here is T, here is T, so it is T. Here is T, here is T, so it is T. So the rest, they are false. Very good. I've now validated this one. Now it remains this statement now that have been combined, and this one that have been combined by this conditional connective. They have been combined by this conditional connective, the last one. That this statement now and this statement. So we are looking at this one and this one under this connective and under this connective. We are going to use it to evaluate this connective. Now, and you know that you said that here is antecedent, here is consequent. So I know that it's going to be false when the antecedent is truth, while the consequent is false. So here we have T, no, false, false, no, false, T, no, false, false, no, T, no, false, T, no, T, no, T, no. That means they are all truth. That means here is truth, 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 truth. That means the statement is being evaluated to be truth or true. All the truth valuations for the statement form, they are all true. That means you can see it here, the main connective that combine the two statements together, they are all of them, they are all truth. So that is proof that it is tautology. The statement is tautology. So that is how to prove tautology statements, or how to prove statement form to be tautology under truth table. So you have proved that now. I have seen that the whole valuations of the statement form is true for all possible combinations. So that is means that it is tautology. Let's use now. We want to use truth. We want to use assumption of a truth value. Now, you say use assumption of a truth valuation to prove P implies Q and Q implies R implies P implies R is tautology. Now I want to use assumption of a truth valuation to prove that this statement P implies Q and P implies R implies P implies R is tautology. You know that you have two methods where you can use to prove a statement to be tautology. We have used one, truth table. Now I want to use assumption of a truth valuation. Now we know that this is the main connective of this statement. If you remove the outer bracket, you know that this is the connective that combines this statement and this statement. So that is the main connective. And we said that it can be only the here now has been, here is now antecedent, while here is consequent. And it can only be related to be false when antecedent is false and the consequent is true. So here we are going to assume that it is false. Assume that it is false. So the statement is false. That means we assume that it is false. If it was contradiction, you know that it is because that is we assume that all the valuations they are truth, as we have done in truth table, they are truth. So anywhere we have contradiction that is not false, that means it is truth. So, and that means that if here is false, it means that this one is truth, this one is false. I call here, I call it line 1. I'll bring it here. 1. Then, if that is the case, it means that this one, this statement here is true. This one is false. Alternative, that means this one, this statement, when it's being validated, it will be false. While this one will be true, so it will be false. To go further, we continue with this one, call this 2, line 2. You come here, P implies R. We write it can only be false when P is false and R is true. That means P R, then P is false and P is true. R will be false, P will be true, then R will be false. That is that. You call it line 3. Then we come here, having known that here, this one, P implies Q, will be truth, for it is true. This one is true. That means here must be true, here must be true. The two conjuncts must be true. That means here is going to be true, here also will be true. This statement will be true, this statement will be true. So it can be true. So if this one is true, it means that P implies Q, that means Q must be true. Q must be true. So this one can be false, this one can be true. So here, since it is true, we write this one is true, this one also is true. Assume that it is true. They call it, here is line 4, here is line 5. Is line 5. Then they come to this place. You have known that Q is true. Why you use here true is that you already see that P is true here. That's why you use truth here. Here, you know that Q and R to be truth. That means R must be true and Q will be either true or false. But you already see that Q is true here. So you're going to give true here. So here, you see that I've already seen that R is false, so R is false here. And then Q is true here. That means line 6. Now you can find out that here R is false, R is false, and Q is true, and that should give us false, but it is true. So that is contradiction. So here we say that Q implies R is true, but based on our combination of truth and truth values of statements, we find out that we have already seen that R is false here, right false. Then Q is true here, right true, but it is T. So it is, that means that is contradiction. And also if you say that let's make it to be true, that means we assign R to be true, then Q to be true. It means that R assign both truth and the false. That means here is true, here is false. That means R have truth and false value, which is wrong. So based on this, we can then conclude that it is tautology, because there's no way you will assign the truth value to give us false. That means that by assumption, we then agree that the statement is tautology. You say that. You say there is contradiction or there is contradiction in this line 1 so know that this is line 5, line 6, line 7. Very good. So here you say there is contradiction in line 4 and line 7, where the statement Q implies R is true, but Q is equal to T and R is equal to F. Means D Q implies R is false. That is contradiction. We say that there is a contradiction in line 4 and line 7. That means this line where the statement is true. Then in line 7 where P implies Q is true, because Q is true, R is false, but it's been related to be true. That is contradiction. So by this assumption, it proves that the statement is tautology. Therefore, the statement form is tautology. So based on this, the statement form is tautology. Thank you, viewers.